section 10.7 is called polarity test. And we're going to look at a method that we could use to determine the polarity of a transformer, whether it's additive or subtractive polarity. And notice, at the end of this thing, we're actually going to walk through an example where we connect a low voltage source to this transformer. Even though it's made to operate at much higher voltages, we can use just a 120 volt source to make this test to determine the polarity. And I know you get tired of hearing this, but this is actually something we do in a lab where we go through and make these determinations. But of course, we can't do that. And of course, at this stage, I was hoping that we would be able to do that, but we're still not able to get into the lab and do these things. And then the last thing I'll say is, please be careful. If you're ever at the workplace, you should never be put in a position to where you're making voltage measurements outside the facility, right? I mean, that's Duke Energy, the guys in the truck, right, that go through and do those kind of determinations. I can't think of a situation that you would ever be involved in or should be asked to be involved in where you're participating in measurements at, say, a transformer level outside a building, at 14,400 volts. I mean, that's just not somewhere we play. Everything that we talk about should be done within the, after the entry point of the voltage to the building, and we're looking past a control panel or that sort of thing. And, I know that's obvious and all, but, sometimes you're the electrical person and you're determined as the go-to person and everything, right? And it's just not somewhere that you can be experimental. You have to know what you're doing. Okay, so let's walk through the method that we could do this polarity test on, and it involves figure 1011. Okay, so while you're looking at 1011, I'm going to kind of walk you through what's going on and how we would make this polarity test, and I'll do some highlighting for us. Okay, to determine whether a transformer has additive or subtractive polarity, this is one method that we could use. We could start by connecting the high voltage winding to a low voltage source. So let's put 120 volts AC on the input side here as the source voltage. Now, we're going to take a jumper and we're going to connect between any two adjacent high voltage, low voltage terminals, okay? And we could have done, any two adjacent. We could have gone, from here to here like we did. We could have gone from here to here like we did. Either one of those would allow us to perform this determination, all right? Now, what we're going to do is next, we're going to connect a voltmeter between the other two terminals that aren't jumpered, okay? So notice that would be this terminal here and this terminal here, okay? So that's what we're looking at in terms of, how we connect this. If we had done this the other way, going from here to here, we'd be connected to here and here. But that's not what we're doing in this particular example. We're following through as he's telling us here, okay? Now, we're also going to connect another voltmeter on the other side, and this is our primary voltage, E sub P, and we're connecting that across the high voltage winding, okay? So notice, and this is one thing I want to point out to you, and I always do this in class, but I think it's even better with this slide. The E sub X, it's not from here to here, right? It's connected across the two terminals that aren't being jumpered. So make sure that you understand that. Now, he goes on to say, and then I'll try to give you an explanation as to why this is if it's not clear to you. He goes on to say that based on our configuration, if E sub X gives a higher reading than E sub P, then we are looking at additive polarity. Okay, which also goes to say if E sub x is less than E sub p, we're looking at subtractive polarity. Okay, so that's what we're looking at. All right. Now, if and before we even go into the explanation, if E sub x gives this higher reading, and we're saying that that's additive, then that tells us that H1 is diagonally from X1. And that was by definition earlier here, right? So, just so we see that. All right, so that's where that's going. Okay, so let's go back to a little explanation on this. So we're saying E sub x is greater than E sub p, it's additive. E sub x is less than E sub p, is subtractive. How do we know that? How do we reason through that? Okay, so I went back to this figure, and I sort of redrew this, and so I'm going to read to you. I want you to look at this while I'm reading. But in this polarity test, the jumper effectively connects the secondary voltage here, right? Let me do some highlighting. The secondary voltage here with the primary voltage here. That's what the jumper does, right? It just, whatever level this side is, you're going to get the same over here because it's jumpered over. So what happens is this E sub s voltage, that is this, right, from here to here, it either adds to or subtracts from whatever E sub p is here, okay? So in other words, if you look at that thing and you say, okay, E sub x, what we're reading here, it's either E sub p plus E sub s, or it's going to be E sub p minus E sub s. And that depends on the polarity. And another thing too, I'll point out right here, in making this test, we use an ordinary 120 volt source, 60 hertz, and that way, it's connected to this high voltage side, and that way you could actually do this test and you could actually do it safely. And that might be something that a technician or engineering technologist might be doing with a particular transformer disconnected from the very high voltages. Now, we're going to go and continue with this, and we're going to look at an actual example with some numbers in it and see what this looks like. Okay, so in example 10.3, it says during a polarity test on a 500 kilovolt amp, 69,000 volt, 600 volt transformer. Of course, what that means is this would be the primary, this would be the secondary. So it's a step down transformer. We got 69,000 in and 600 out. We made the following determinations. We found that the primary voltage was 118 and the E sub x voltage was 119. Now, he tells us, and we'll try to reason through this as well, he says the polarity is additive because E sub x is greater than E sub p. All right, so that in and of itself, based on the conditions of the test, tells us that it's additive. And then he goes on to say that high voltage, low voltage terminals connected by the jumper must be respectively labeled H1, X2. Okay, so that would tell us, that since additive would be in this direction, we've determined that it is additive. So that means we'd label that as H1 and that as X2. We would know that. Now, before we go into this figure 10.12, I want to try to give you some a little bit better explanation on why that is in case that's not obvious to you. Okay, and here again, this is my attempt. I don't know how good it is at explaining why this works out this way. But again, remember if the E sub x is greater than E sub p, the actual polarity markings would be additive, like I'm showing us, here with the connection scheme. All right. So, we're 118 at this point, and then this is jumpered across. So, you basically, what you're basically saying there is that you're putting the secondary in series with the primary. And so, this is either going to add to this or it's going to subtract to this. And, if this is the way, we're looking at it, this is the way we're looking at it, the connection would show here that, we're actually, we're actually adding to the total voltage this way as we look at this. And, so we know that, this is the positive, this is the negative, this is the positive, this is the negative. And, there's that increase, there's that increased voltage to demonstrate this additive situation. But anyway, I don't want to wear you out on this, but the last thing that he shows us is figure 1012. And this is another circuit that can be used to determine the polarity of a transformer. And in this case, we're using a DC source, and it's connected with an open switch. It's connected to the low voltage winding. Okay, so it's connected to the low voltage winding here. And then the transformer terminal connected to the positive side is marked X of 1, okay, here. A DC voltmeter is connected across the high voltage side. When the switch is closed, a voltage is momentarily induced into the high voltage winding. If at that moment, and it's just, it's just a moment there because of DC voltage, transformers aren't designed for DC, but if that moment the pointer of the voltmeter moves upscale, the transformer has connected across the positive terminal of the voltmeter marked H, and the other one would have to be X2. So, H2, I'm sorry. So, just two different ways to actually do these polarity tests. So I'll stop with that. Let me know if you have questions or I'm not clear about the meaning of the readings.